Hello friends, welcome to Power Electronics practical session. Okay, so myself Mr. Yuva. Today we are going to discuss about the practical performance by using a PSIM software. Okay, so power electronic circuit can be simulated or can perform by using a PSIM software. So that is it is for the as per the syllabus of Savitribai Phule Pune University. The electrical engineering students have this particular practical in the syllabus, and the electronic students is also having this particular practical. So all the students, those they wanted to get a knowledge and they want to expand their knowledge in PSIM software. So it is the software which will be used to design the power electronic circuits by using various loads. Okay, so you can perform a number of power electronics design here. So there are so many design you can do it by using this PSIM software. So today friends, we are going to see the three-phase fully controlled converter for 120-degree conduction mode, and by using here we are using resistance as a load, and with the help of PSIM software we are doing this. Okay, so let us start with this one. So this is initially you just create a new workspace. In this new workspace, so you can have here tool, you can see what are the tools file. Okay, here you can give the new name, that is new. If you create the new, and then you can do the save. Okay, and then check elements, what are the elements are there, status bar. So this is the library there where you can see the different elements which are required for this perform the you can say the projects, you can say the practicals. Okay, so whatever you want to design, that power electronic circuit has to be designed with the help of some load you are going to connect, and you are going to observe what is the variation which is coming by providing the firing angle to the different circuits. So that all the things we will cover up here. So here you can see these are the various tools are there that you should know. In the next coming lecture I will be telling that I will be explaining you all that regarding how to use these tools, everything. Okay, now quickly we will take three-phase supply. Okay, here there are different components are there. If you want you can take it. So I required a three-phase supply. Okay, AC supply. So therefore I will click on element and power, then we require the source. Okay, then I go to source and voltage from here. So we require three-phase AC sine wave. Okay, that is supply. Okay, so click at this particular point, and then go to the we required SCR. So here we don't have any SCR. So therefore again you just go to the element, or you can go to the library even. So there also you will find it. Okay, so you can go to the library, and from here you just do the search. Okay, in the search engine, so thyristor, if you click on the thyristor, so you will be from the library you can search it. Okay, so that is when you put it as thyristor, you will get the thyristor. Okay, so select this particular thyristor, and then you just cancel it and just rotate it as per your convenient. Okay, so you have the circuit configurations like this. So we require total 6 controlled switches, 1, 2 and 3, and then after this again there are 3 switches are required. So those 3 switches you connect it at a lower limb. So we will call it as a lower limb, and this is for upper limb. Okay, and this is the three-phase supply voltage. After this, we required a resistance. You take resistance from here and you click it, and it will be pasted here. And we required, apart from this, we required ammeter. So this is the current probe, which is called as an ammeter. You just click it at this and click at this lever. So take this wire, and this wire you just connect all the elements internally like this. Okay, so to avoid any error, getting any error, so we will do one thing. We will align these switches as per like this. Okay, and this also you just align with this one, so to avoid the errors. Okay, when we want to run this particular circuit, so during that it should not give any error. Now this ammeter, you just connect it like this and connect all the connections like this. Okay, and you extend and connect this also like this. Okay, so this and this, do the connection properly like this. And so this is the three-phase input supply voltage. So this you connect with at this point, say it is A and say it is B phase, and this is the C phase, A phase, B phase and C phase. So after this, we want to measure the output voltage, and this is the output current, and we want to know what is the input current as well. So for that we require this voltage probe. Click on this, and we require 3 for 1, 2 and 3 for phase A, phase B, phase C. And again take the wire, you just connect it from here to yes, like this. Okay, okay, then you connect this and this as well. So this point is connected to A, and this point is connected to B, and this point is connected to C. Okay, fine. So we got everything, and we required one more, that is voltmeter, to measure the output voltage. For that we will take this voltage probe, and this voltage probe can be placed at this side, and you just connect it with this circuit. Okay, yes, like this. Okay, fine, it is looking fine. So now what is required? The required is the gating block is required. Okay, to provide the firing angle to these switches, thyristor, we required a gating block. So choose this gating block, and you just rotate it and connect it for all the switches like this. Okay, okay, we have done it. Now the thing is that you just we need to mention the names. Okay, proper naming convention is very important, because at the time of getting the final answer, you will come to know that which variable is what. Okay, exactly, you will get the idea. So therefore I will click on this, and we will take a line to line voltage, that is 230 volt, and the frequency which we are operating, that is 50 Hertz frequency we will take, and this is the input source voltage. Okay, if you want to display, you just click on these buttons, these boxes, it will be displays what you have taken the specifications. Okay, then it is finalized the input, 3-phase input AC supply voltage, and you just click on this and mention it is V1, mention it V1. Okay, and then you put it V2, this is the V2, and then it is a V3. Okay, fine. After this we will try to name this ammeter. So this ammeter, the current probe which we connected, so it is the output current, so therefore we will take it as a I0. After this you just click on this and it will be given like this, and tell it V0, that is it is the output voltage we get. And the load resistance which we have connected, so that is V0. Okay, otherwise you can take it V load, and the load resistance will take it as 100. Okay, so you can take more or less than that 100 value as well. So after this we required to name these all the switches. Okay, so as we know that this 3-phase fully controlled converter will operate based on the 3 different modes of operation. So during first mode of operation, switch, this is, so we will mention first the switch's name. Okay, we have not mentioned the switch name. So this is thyristor 1, and then this is thyristor 3. So next is thyristor 5. After this, so this is the thyristor 4. So it is there is no need to make any changes. So this is a thyristor 6. Okay, so change it 6, and this is the thyristor where it is the thyristor 2. Now you can see there are different modes of operations will be taking place in this one. Okay, so during that we'll try to understand. Okay, so we'll do one thing, we will go on this particular one node, and there we will just try to understand what are the different modes of operations. Okay, just a minute. Yes, I think it is opening. Yes, so we'll take a draw. Okay, so I'll take this. So here what we'll do, so there are total 6 modes. Okay, modes. So first mode will give you the conduction of the switch, that is thyristor 1 comma thyristor 6. Okay, it's very important. And during second mode of operation, the switches 2 and 1 will be conducting, and during mode 3, the switches, that is thyristor 3 and thyristor 2 will be conducting. After this you can just take it at mode 4, the switches, that is 4, thyristor 4 and thyristor 3 will be turned on. 4 and this is 3. Okay, and then the remaining is when you go for the mode 5. Okay, so mode 5, during mode 5 that again 2 thyristors will be turned on, that is thyristor 5. Okay, thyristor 5 and 4, 5 and the 4. During last one, that is 6th mode. Okay, during 6th mode the thyristors 6 and the thyristor 5, these are the 2 thyristors which are conducting. So it is very important, so we need to understand these things. Okay, and after this, so these are the total 6 different modes of operations which will be taking place. During first mode 1 and this is the 6 switch will be turned on. During second 2 and 1. During third mode of operation 3 and 2. During fourth mode of operation 4 and 3. And during fifth mode of operation 5 and 4. During sixth mode of operation 6 and 5. Likewise, there are different 6 modes of operations will be taking place. So this is when we want to perform the based on 120-degree conduction mode. During that, one switch from upper limb and one switch from lower limb will be conducting at a time. Okay, so when you see this one, so according to this, you just see this is thyristor 1, 2, 3, 4, 5 and this is the 6. Okay, so during first mode, as we know that thyristor 1 and 6 will be conducting. Okay, so based on that, different modes will be operating. So we will need to provide the firing angle for all the thyristors. Okay, so for thyristor 1, again we will go on this one, and then based on that we will try to do that. On this particular thyristor, we will try to mention what are the conduction period of the thyristors, all the thyristors. Okay, so we'll add one more page. Okay, it's a fresh page. So here you can see this is a T1, that is thyristor 1. In the thyristor 1, it conducts from 60 degree to 65 degree. Okay, say, and T2 will be conducting from 120 to 125 degree. Okay, it will conduct like that. And when you see thyristor 3, that is T3, will be conducting from 180 to 185. Okay, then the next switches are, if you want you can take some other colors as well. Okay, so during thyristor T4, okay, for thyristor T4, what are the switching sequences has to be given? So it will conduct from 240 to 245. Okay, 245. And then thyristor 5, this thyristor 5 will conduct from 300 to 305. Okay, it conducts to 305. Then the final last is T6. Okay, that is thyristor 6. So it will conduct from 360 degree to 365 degree, 360 degree to 365 degree. Okay, likewise these are the switching sequences of all the thyristors which are to be performed. So now we will see. Okay, so we'll try to perform the same thing on the by using this circuit diagram. Okay, so I'll click on this gating block and I will mention it. Okay, so what we have to mention, the frequency is 50 Hz and the gate G1 it is, and the switching sequences or the switching points, you can call it as, it is 60 to 65, which we have discussed. Just click it, and if there are 2 points, you just mention it number of points as a 2. If there are 4 points, you just mention it as a 4. So when we are performing the next, we will try to see that. Then we'll substitute the values for, this is G2. Okay, so this is the 2 and the frequency is 50 Hz. Then the switching sequences are 120 to 125. Okay, then the next is thyristor 3. You put it 50 Hz and the gate is G3, and then the sequences are for third thyristor 3, 180 to 185. Okay, then fourth thyristor, give it a 50 Hz and this is the 4, and then the sequences are 240 to 245. Then the fifth block, that is switch, give again it is 50 Hz and you make it 5, and the switching sequences are 300 to 305, and the last one is, that is thyristor 6. So again you just mention it G6 and the frequency is 50 Hz. Switching points are 360 degree to 365 degree. Okay, if you want you can put it for mentioning. So I think we completed all the requirements to perform this particular 3-phase fully controlled converter for 120 degree conduction mode of operation. So the next thing is, we required a simulation control. So put it and take a total time of 0.04. And then go to the simulation and run the PSIM simulation. So yes, perfectly we got, and there is no without error we got this particular properties. So here there are variables, available variables are there: output current, and this is V1, V2, V3 are input current voltages, and V0 is the output voltage. So initially we will try to take this input voltage at a time. Okay, so see how nicely it came. Okay, this is the input voltage which we got from the circuit there. Okay, after this we want to know what is the output voltage. So this is the output voltage, and then click on make it OK, and you will get the output voltage. Okay, so even though this is the there are three phases are there: V1, so this is the color V1, V2, and this is V1, this V2 is red, and the blue is V3. So likewise three phases are there, and this is the output voltage which we get from the circuit. And if you want to know the output current, so just add it and you will get the output current as well. So this is all about the three-phase fully controlled converter by using 120-degree conduction mode of operation, the waveform by considering the resistance as a load. So by in coming video lectures, so we are going to perform by using the inductive load. What may be the changes, at what type of waveforms we are getting at the output side with related to the output voltage and the output current. So that we will see in a coming video. Thank you.